a basic data science, what exactly the data science means, and how we're going to use it in our day-to-day life, and what is the impact of it in the industry. Okay, those are the aspects we'll be covering in the next 30-minute session.
Okay.
Right? Please feel free to ask any questions in between. Okay, you can stop me if you are not getting. Right?
Yeah. Okay.
Right. So, yeah, Hema, like, what do you mean by data? Let me ask this question to you.
Data.
Yes.
It's
What's the
an
data?
information about it's an information. Maybe it will be in quantity.
Correct. Correct. So any information carrying entity is called as a data. Correct. So it may be a numerical, it may be a kind of this categorical, whatever it may be, right? So maybe an email is the data, image is the data, video is the data, text is the data. So every day, whatever the information you are consuming, everything is a data. Right?
Yeah.
So let me take you to the next slide. Yeah. Like if we can make out something out of the data which is available to us, that is called as a data science. Right. So suppose, if you look at the formal definitions of it, like what is data science? Data science is the study of data, including its collection, analysis, and interpretation. Okay. So, suppose you have a data, just you have to collect it, you have to analyze, maybe by using Excel sheet or Tableau, whatever visualization tools should be there, right? With that data, you should be able to draw some conclusions. So, what are the patterns lying in that data? So, how can you consume that patterns in your day-to-day life or for your business cases? Correct. So that is called as a data science, basically. So the other definitions, like it involves the applying various techniques and algorithm to extract the valuable insights from the data. This is also a kind of a data science definition only. And again, you can give like a data science is a multidisciplinary field that combines the statistics, mathematics, and computer science. Statistics means basically hypothesis testing, the R square and other MSc and those stuff, accuracy matrices, they will come from the statistics. Okay, maths means algebra, differentiation, calculus, that come from the mathematics, and computer science, you know, the language like programming language. So all together will form a data science, right? Okay. Till now you are clear, right?
Yes.
Okay. So, data science, like suppose if you are working as a data science, there are certain steps involved in for every problem statement. Okay. The first step will be the identifying the problem. Like first, like suppose the problem is related to which industry, like is it related to a retail or a BFSI, means banking finance, or is it related to manufacturing? So that is called as a problem identification. First, you should know the domain of the problem. Okay, then once you know the domain and like what exactly needs to be solved, you will go for the data collection. So the data collection, what I'll do is like just I will overview all the points and just we'll take one by one in the next consecutive slides. Okay. Second step is data collection. So you have to go to the field, maybe, or go to the vendor to collect the data, or it may be available in the websites as well. Just you have to download and prepare the data. Data pre-processing. Okay, clean the data and prepare for data analysis. I will explain it in the next slide. Okay, exploratory data analysis, then modeling, and then evaluation and deployment. We'll take up each point in the consecutive slides. Okay. Before that, just I will ask one question to you. Okay, you said data is like anything which is carrying information is called as a data, correct? Do you know how many types of data are there? Basically, if we talk in terms of data science.
Types of data and what are they?
Sorry, could you please come again?
No, types of data means actually according to the domain, we can segregate the types of data. Right? For example, image processing means the data will be in image form, and in electrical side means some metering data they are in numerical form. So
Correct. You are close to the answer. Yes. So that is well taken. Yeah. Thing is, so with respect to the data science, right? So I mean, the form in which the data exists, based upon that, we can classify them as a structured data, unstructured data, and semi-structured data. Okay, structured data means like suppose you know the Excel sheets, right, and the SQL databases and tabular forms, right? So like you can see them like they are very well organized. There will be a columns, there will be a rows. There won't be any confusion, correct? So that is called as structured data. One, you can feed the data as it is to the models. So model will easily understand it. There will be a kind of a certain format for the data. That is called as a structured data. So the examples just now I gave, right? Excel sheet, maybe a SQL databases and web form results, that kind of thing. Right? Second one is unstructured data. Unstructured data means like something which you cannot like make out of, like the data which is not having a certain format. Like if you look at the previous case, Excel sheet will be having the .csv format, and that kind of format will be there, right? And the data, like anybody can decode the data. In case of unstructured data, for example, email messages, you cannot extract the information out of it so easily the way you can do it in the Excel sheet, correct? And the videos and this surveillance camera footages, they are the examples for unstructured data. And the third one is semi-structured data. Suppose, like, are you aware of the this one XML files, JSON documents? Have you ever come across this XML files? Okay, we'll cover during our course. Yes, this is also a form of a Word document. Where the extension will be in XML files. Like maybe you must have seen the HTML course, right? HTML. The form of XML and JSON will be in the HTML format. Okay. That is again, it requires some sort of a pre-processing or some sort of extra tools or techniques to extract the information out of it. That is the reason we are calling that as a semi-structured data. I hope the things are clear, right? Till now?
Yeah, yes.
Okay. As I told you, there are several processes like in the data science, correct? There are around 8 steps involved for every problem. Like suppose in future, if you want to, like if you become a data scientist, right? So if somebody, like maybe a client come to you and they will ask like, I need a solutions for this. You have to follow some standard protocols or procedures to attain the goal within a particular time. Correct? They are called as SOP, standard procedures. So yes. So the first step is like as I already covered, problem identification. Assume that you identified the problem. For time being, like we'll take an example of maybe a sales forecasting. Suppose a retail customer comes to you and he want to understand his sales forecasting for the next 2 months. Right? That is the problem statement. Now the next step is you will go to the field or you will go to the vendor or you will go to the client and ask for the data. Give me the data. Right? So data is the main feed for the data science. Correct. So while collecting the data, you will check for the data quality. Means just now I explained to you what is the data format, whether the data is correctly given to us or not. Right. That is called as a data quality. The sources of data means like it may be a website, from website you can download, or from maybe a hard copies you can get it. That is called a source of data. Data collection method. So just now I told you like you can collect the data from anywhere, like maybe like based upon the client requirement. Right. So data cleaning. Next step is data cleaning. So this is the most important step in the data science. Okay, if you don't clean the data, your model will not behave properly. The final model you are going to develop, right, for your customer or client, so that will not behave accordingly the way you want it. That is the reason we need to clean the data. Assume that you have collected the data from your retail client, okay, in the Excel format. The Excel format, okay. First step is you need to identify whether the data is complete or not. Are there any missing values? That you have to check. I will tell you how to replace or how to deal with the missing values in our course. Okay, just like for time being, I will not cover this. Like I will have to go for other calls also. That is the reason. And the next is removing the duplicate data. So if you keep like suppose there are more than one row which is having the same information, it doesn't make any sense. Correct. Unnecessary, it will consume the space and it will overfit your model. So again, I will like cover the overfitting and underfitting conditions in our course. Like just like for timing, like just stick out to this only. Data transformation. Okay. Suppose if you have the if you have the data in a high dimensional means assume that like you have a Excel sheet in which 1,000 columns are there and 2,000 rows are there. Okay. All 1,000 columns are not necessary, right? So they might not be having the relevant information. You need to discard them. You need to bring the high dimensional data to the low dimension so that your model can easily consume it and make the proper decision about the data. Okay, that is called as a data transformation. It involves many steps like normalization is also data transformation, min max, that kind of thing. Okay? It is a data transformation. Yeah, right? Data cleaning part.
Yes.
Okay. Next step comes data exploration. Now you have to analyze your data. Like what is the relationship between each column and the target variable? What is our target variable? Like target variable is how much sales can happen in the next 1 month. That is our target variable, correct? What are the independent variables? Independent means variables which are going to contribute predict the target variable, right? So for example, the store location, the footfall for the store, the day on which the day the day okay, so the month of the day, so the day of the month basically, sorry, those are the independent variable, right? So we need to analyze what is the relationship between the independent variable, like what is the store opening timing, that kind of thing, right? So there we need to do a kind of analysis. You can use a histogram, line graph, or a pie graph, whatever the relevant one. Just the main purpose of data exploration is to understand the patterns or a data in between, right? And like you can plot a heat maps also. Heat map, you know, right? Heat map correlation graph.
Yeah, I heard about it.
But just to check, like whether the independent variables are really contributing to predict the target variable or not, like based upon the correlation coefficient. Correct. If the correlation coefficient is very high between the independent and the target variable, then obviously the variable is making sense to keep in the data, right? Or else you can discard it. That is the reason we'll do the data exploration, and you can plot the box plots also. You know the box plot, right?
Yeah, I heard about
What's the
that.
like in the data science, the purpose of box plot is to remove the outliers. There will be some exceptional cases, right? So they will not be according to the normal behavior of the data. So that those outliers you have to remove, or else it will cause the problem in a final model.
Okay.
This is the purpose of data exploration. Next up is like again, it's like data exploration and data visualization are more or less kind of the same. Data visualization is comes like suppose once you build the model, you have to explain the same thing to your client, right? That time, like you will ask what are the process you followed and all. That time you need to showcase the graphs and like you need to show them like the heat map and other stuff. So what was the relation and how did you overcome it? What were the pre-processing involved, right? For that purpose, you are using the data visualization.
Okay.
Okay. So next, this is the final step. Once your data is ready, like you clean the data, you pre-process the data, or now assume that your data is in a standard format. Standard format means like, suppose if you take an example of a retail forecasting only, the sales forecasting. Okay. So what is the standard format? Like the rows and columns should be there, the target variable and the independent variable should be there. No missing values, nothing. Although each column should be having a similar data type. Similar data type means int, numeric, or categorical kind of thing. Okay. So once like your data is ready and it is in the standard format, next step is you have to fit the model. Okay.
Yeah.
So this is a part of machine learning. Okay, machine learning, you might have heard term, right? So this is a very buzzing word nowadays. So data science means like dealing with the data, then like modeling will comes, right? So that is again a machine learning part. So once your data is ready, next like the selection of the model will come. So there are three types of models. One is supervised, unsupervised, and the supervised, unsupervised, and semi-supervised basically. Supervised means in the case of ours, like we have the independent as well as the dependent. Means it is called as a labeled data. Correct?
Yeah.
You know the X as well as you know the Y. Right? That is the reason we called it as a labeled data. So whenever you are consuming this kind of a data and you are fitting the model, that is called as a supervised learning. Means for the model we are throwing the labeled exam. Okay, that is super. Like you can take an example of nearest neighbor, image classification, CNNs. These are all supervised learning basically. Unsupervised learning means you will be having only this one. What like the X means an independent variable, not the dependent one. I can give an example of clustering. Clustering means suppose you have a city in which 1,000 people are staying. You wanted to classify them based upon their the appearance or maybe the way they consume the foods, right? So there won't be any kind of a target variable here, right? So you have to look into the behavior of them and you have to separate them into clusters or groups. This is called as unsupervised. Okay. So these are the two types, and semi-supervised means like partially using the supervised data and like means labeled data and partially using the labeled data. That is called a semi-supervised. We'll cover in depth. Okay. So yeah, this is the overall process. the kind of protocol any data scientist has to follow for fitting the model. Okay. Now
Okay.
comes to the application of data science. So data science, like it is like you can consider data science. Nowadays, data science is being used everywhere, like in any industry, like healthcare. You can take marketing, business, retail, BFSI, manufacturing, everywhere. Okay, even in terms of like education industry or edtech, right? So maybe a
Okay.
Byju's kind of an academy and all, right? So they
Okay.
everywhere we are going to use a data science. Like if you look into any company, so there will be a team called as a data science. They are separate from the software engineers. Okay.
Okay.
So this is a very common trend nowadays. Like every company is having an in-house data scientist. Because you can take an
Okay.
example of Nokia, right? Nokia
Yeah.
was not aware like what is going to happen in the next 20 years of market, right? They did not do any kind of data analysis. That is the reason they failed.
Okay.
They could not understand the customer needs. Right.
Okay.
So that is the reason it went out of the race. Right. So like suppose if you take a healthcare, na, so there are multiple applications you can make of. Like one is a you can take the famous example is cancer prediction. Like suppose a patient comes to you, like whether he is having a cancer or not. So what will be the data type? Like it will be a numerical form. Whether like what is the age of him, what is the blood pressure, what is the blood cells, like all the features will be there. The target
Yeah.
also will be there, like whether he's having or not. That kind of
Okay.
thing you can make. And you can even analyze the X-ray images also. Based upon the
Okay.
X-ray images, you can tell whether he has to go for the further diagnosis or not. Okay.
Okay.
The accuracy will be up to the mark. Not exactly, I can say it's 100%. Maybe 90 to 90%, 25% you can expect. Based upon the data quality, you can decide it. Okay. Suppose if you look into the banking and finance domain, right? So there you can take an example of credit card. You can the applications of data science in the finance are like you can identify the fraud, whether the transaction made by the customer is a fraud or non-fraud. That kind of thing. And for even for lending, like suppose if a bank is willing to lend some money to the customer, then it has to look for the risk factor associated with him, right? Be a CIBIL
Yeah.
score, then whether he is going to repay the loan or not, that kind of stuff. Okay. The next one is in algorithmic trading. Like this is very common nowadays, right? So the big companies like Goldman Sachs and all, they're using algorithm trading to invest their
Okay.
funds in the stock market, right? So if you come to the
Okay.
marketing, like just now I gave an example like sales forecasting, you can say, and customer segmentation, like this one, the unsupervised classification. Based upon their spending behavior, you can segment the customer and you can personalize the offers for them.
Okay.
And the next one is retail. Retail, like again, yeah, you can look into the inventory management recommendation system. This is a very famous one for Amazon, Flipkart, wherever you go for the e-commerce website. Whenever you are purchasing some particular product, along with that product, you will get a suggestions also. Correct? This is a very common experience. Everyone must have experienced it. Correct? And yeah, like these are all the fields. Like you can make use of the data science to increase the productivity and mitigate the cost or reduce the cost and human intervention. Right.
Okay.
So this is all about data science and like what are the challenges? Like if you go to the industry, what are the challenges you're gonna face? Right. First of all, the data quality, like the format of the data will not be same.
Okay.
Like sometimes you might receive XML data, sometimes you might receive a data in the form of JSON, sometimes you might receive the this one data in the .json sorry this one like .cs format or images. Like you need to do a kind of lot of pre-processing and cleaning steps. Okay.
Yeah.
And the next step
Okay.
is you have to preserve the security concerns of the client. Okay, that comes under
Okay.
data privacy. Scalability. So while building the model, you will be having a very less data. You can easily do it on our local machines and a basic Google Colab and all, right? But when it
Yeah.
comes to a production level, so the scalability issue will come because it has to be in a real time. It should not take much time for prediction, correct? Suppose
Yeah.
a customer asks a particular question, it should be able to handle the or process the query in a real time. That is called a scalability, and it should be able to expand to any number of queries. That is scalability. So here, like the
Okay.
picture of AWS, Azure will come into picture. Okay, cloud basically.
Okay.
Interpretability. Sometimes what happens, the model will give a prediction in such a way that even we cannot interpret it. Okay, that is called as interpretability issues. ethical issues, gender biasness, and that kind of thing. Talent gap means like in the industry there is a huge demand for data science, right? But we are lacking in the talent, like in this particular domain, right? That is a talent gap. These are all the challenges in the data science, basically. Okay. So, what's the future of data science, right? So, like, suppose if you complete a particular course related to data science, you can work as a data analyst, a business analyst, a data scientist, maybe machine learning engineer. They're all career opportunities anyone can have after going through a courses like data science, machine learning, and all. And this data science is not going to die, at least for the next 10 to 15 years, I can say, because I was in industry since last 4 years, right? So based upon that, I can say, like, because without data, you cannot do anything in a nowadays market.
Yeah.
You can take an example of Hotstar Disney. That is also lacking in data science. That is the reason it's becoming absolute. That kind of thing.
Okay.
So the feature is very good, and like you can get into any AI stuffs. Maybe you heard the Elon Musk, right? So he's a guy like who is hitting the AI, right? So that on automation, big data. So if you know that data science, you can get into the big data domain as well. Big data means like basically dealing with a large amount of data where like continuous streamlining should happen. And IoT, like, do you know the IoT, right? So Internet of Things, collection of the data from the IoT devices and processing them and taking the decisions, that kind of. So explainable AI, ethical AI. Now, like there is a like buzzing word called as a generative AI. So you know about LLMs, right? Large language models. This is a very famous nowadays. You can do anything like the content writing, everything, like all the stuffs like which a basic entry level engineers do, right? So that can be done with the help of just a single LLM. That much capability it is having.